We are discussing the physics of swingouts, a graph to show the position of lead and follow in a 1-4 swingout. Here we have a graph. Well, here we have a lead and a follow. So we're measuring the position of the lead and the position of the follow. So I'm defining x to be the position measured that way for some reason. So here is a graph. On the x-axis we've got the beats of the bar, starting with 1 and ending with 1. And the position of the lead varies in this fashion. So you start off distant, as you lead in on the 1, and the 3 you cross each other as close as you can. On the 4 you're in kind of almost a closed position, and then there's a strong goosh, and then on the 5 you pass each other again, and then the lead heads out, and then you have a kind of a flat region out here where the follow's doing cool swivels. If you are doing it in a slow fashion, you can have a version where the lead does everything about a beat before the follow does it, and this is the way we generally teach it. In particular, we say that on the 4 you're in closed position, and on the 5 the lead steps back and the follow steps forwards. So in this fashion you find that the centre of gravity of the couple, which is halfway between these two lines, is actually moving. It goes down there and up there and down there. So this means because the centre of gravity of the couple as a whole is moving, you can only do this version of a swing out slowly. If you want to do a swing out fast, you've got to have it's really helpful to have the centre of gravity staying constant, so that way you don't slip over. Anyway, ignoring the slow version, James is here. James wanted to show where the goosh happens and everything. So what we need to do is to take this position graph, and we need to differentiate it first to get the velocity and second to get the acceleration. Okay. So for the velocity, I've actually got this upside down, but it doesn't matter. So you start off 0 velocity, you're just facing each other in open position, and then you lead in, so the velocity starts to increase as you approach each other. The velocity reaches a maximum as you pass each other in the middle, and then the velocity plummets here. This is when you're in closed position. You've got the big goosh, so you're changing direction here. Okay, so you're passing each other. You're maximally separated there, and now you're passing each other the other way, and then you go out, and it kind of flattens off as the follow does her swivels, and then that joins up with the one over here. So that's the velocity graph. So you're moving towards each other. You're moving one way, you pass each other, and then you're moving the other way, and you get back to where you were. Differentiate that again, we've got the acceleration. So the acceleration's non-zero on 1 because the lead's leading in. When you get to 3, everything's completely relaxed, you're just passing each other on a triple step. Then you get into closed position and you get a lot of tension, which is what we refer to as the goosh. We pass each other again on 5. And then there's a tension which kind of stops the follow flying any further out than arm's length, at which point she can start doing her swivels or whatever, and the acceleration is 0 while she's doing that, and then it reaches up a little bit on the 1 when you do the next lead in. So that's our analysis of what a swing out. Well, we know what it feels like. This is why it feels like that.
What's a goosh?
I understand that as a name for this dip in the graph. It's like a lot of acceleration, basically. It's in particular, it also refers to the technique for getting that acceleration, which is you're trying to do it without using your muscles. So you kind of, as you're passing in the middle, you establish a hold, and then the motion you've got at that moment ends up stretching that hold, so you get a kind of an elastic effect. It's not using your muscles really so much as your tendons and everything, which are elastic. And so the acceleration you get comes from that elasticity, and it's much more efficient to do it that way.
Is that a technical term, a goosh?
Absolutely. Absolutely. Yeah, no question. Charleston footwear has a parity property. You can explain this. There are kind of 8 states you can be in. So they form a cube like this. Okay. So I'm labelling each of these corners with 3 letters. I haven't quite finished the diagram yet. I'll finish that in a moment. So the 3 letters here, NNL means. The N means you are kicking in the north direction. So north is a kind of a relative term. It changes slowly during the dance. It's nothing to do with actual compass north. But the point is that in Charleston moves, you always generally turn about 0 degrees or about 180 degrees. So this is like direction which you can track and it will change very slowly, but generally speaking, you can always tell whether you're in the same direction or the opposite direction. So that's what I call north. Okay, so the first end tells you that you're kicking north. The second end tells you that you're facing north. So from this you can deduce that you're kicking forwards. And then the L tells you that you're kicking with your left foot. Okay. So obviously there are 8 combinations of this, because you can have north or south here, and left or right here. So here are the 8 combinations. So if we start at north, north, left, and we do a kick step, we end up at north, north, right. If you do another kick step, you end up back at north, north, left. So if you do a kick hold, then from north, north, left, you end up south, north, left. You're kicking south, but you're still facing north and you're still in your left foot. And if you do another kick hold, you end back at north, north, left. The third thing you can do is you can do a kick turn. So if you start off north, north, left, you end up north, south, right, okay? So you're still kicking in the same direction, but you've turned around and you're on the other foot. And if you do another kick turn, you'll get back to north, north, left. And then there's another move you're allowed to do, which is you're allowed to go straight across the body diagonal of a cube, which I haven't drawn. Okay, so you can go all the way from here to here. So this one down here, I'm guessing is going to be south, south, left, isn't it? So that move, let me get this right. I think that's a fly high kick. I think that's what it is. I'm not quite sure about that. I could have got that wrong. Let's suppose it is. Anyway, the property of this, which is interesting, is that it has a parity property. You never move in 2 dimensions. You always move either in 1 dimension or in 3 dimensions. So it's always an odd number. So if you start on this point here, 2 beats later, you can be on that one, that one, that one, or that one, but you cannot be on that one, that one, that one, or that one. And 2 beats later, you're back on the original set, but you cannot be on the other set, okay? So you can colour these in. So that one's black, that one's black, that one's black, and that one's black. And every 2 beats, you switch from a black point to a white point. And about 90% of all moves in Charleston obey this property. And for the ones that don't, about half of them break the property and then break it immediately again so that you get back into line with the property. So the Charleston footwork, it's not just an arbitrary sequence of kicks, it's half the arbitrary sequences of kicks, which I think is really interesting. And that's basically why a lot of this footwork ends up leadable, because only half the options are actually allowed. So it looks far more complicated than it is.
Yes?
Alright, I'll add one more thing, which is the moves which don't obey this, I've noticed, are the moves that people find difficult. It's really quite striking. So examples are going into tandem Charleston. In that, you have to have the lead break this and the follow not, or alternatively follow break this and the lead not, because the symmetry in tandem Charleston is different from the symmetry in an open position. And similarly, if you want to go into so hand-to-hand Charleston is a really easy series of moves, and open positions, closed positions, are a really easy series of moves. But the moves that get you from one to the other, people find difficult, and the reason is because you've got to break this parity rule. One of the 2 partners has got to break this parity rule. So this parity rule not only is just interesting as a way of explaining what's going on, it's also a way of predicting that certain moves are going to be difficult and working out that you've got to do something clever. This diagonal line down here. From north, north, left to south, south, left. Here's a demo. North, north, left. South, south, left. If I alternate that with a kick step, that'll be a fly back. Okay?